In this video, I'm going to show you how to use AstroImageJ to measure position, angle, separation and delta magnitude of double stars in your images. So first of all, we go to AstroImageJ. First thing you should do is update AstroImageJ to the latest version. So go to Help, click Update AstroImageJ. You want the daily build, click OK. This will download the latest files. There are 3 in total, so this will just take a few seconds. After the files have downloaded, the program will close and then we'll reopen the program again. So while it's doing that, I have been studying a particular star system called LDS 64. And I have 6 science images that we're going to analyse. Okay, so let's open AstroImageJ. Okay, now just a little bit about this system from Stella Doppy, LDS 64. It is composed of a primary of magnitude 10.49 and a secondary of magnitude 12.50. That are separated by 25.1454 arc seconds with a position angle of 268.6 degrees. So let's go to File, Import, Image Sequence. I've already loaded these images, but I'm going to do it as if I didn't have not loaded them. So go to Browse, go to Desktop. There's our folder which has the science images. Press Select. Note there are 6 images here, and we're going to click OK. So this is going to load all 6 images. If I click down here and use the arrow across on the keypad, there's the first image, there's the second, there's the third, there's the fourth, there's the fifth, there's the sixth. Let's go back to the first one. Let's zoom into the image, into our double. Do this using the scroll wheel on your mouse. Now, clicking on this icon here will give you the FITS header, and this gives you all the information about this particular image, everything you need to know about that image. I particularly draw your attention to line 32, which is the date the image was taken, the 10th of the 11th, 10th of November 2025. Line 38, which gives you the exposure time of 20.5 seconds. And if we go down to line 152, it gives you the air mass, which is approximately 1.3. So let's measure these images. So let's first of all see what we need to do. Go to Measure, click the various items here as I have clicked them, unclick right arc length in degrees to table and right arc length in minutes to table. Okay. Now, the apertures here are set so that the central aperture is the aperture that goes around the star. The next annulus out is like an exclusion zone. Nothing's measured in that. And then the peripheral aperture measures the background. Ideally, you'd want to get your aperture pretty much around your primary star. This one's perhaps just needs to be modified slightly. So what I would go to is Set, and I would maybe change that to, say, 5. And leave the others as they are. You can play around with these. The other important thing is to click centroid apertures, and I'll show you why in a moment. Click OK. So hold your your cursor over your primary star, depress the scroll wheel, move across to the secondary star, and then release. And then you've measured that star. So it's got an arc length of 25.15 arc seconds, a position angle of 268.65 degrees, and a delta magnitude of 1.99. So let's measure all the other 5 images. So click on that bar there, arrow across, go onto the second image. You can clear the screen by doing that and do the same again. So hold it over there, over the primary star, mouse wheel, click down, move across, and then release. Arrow across, clear, repeat the process. Now, by ticking centroid apertures, the program will work out where it thinks the maximum value for that star is. So even if I put the crosshair off center here and then click there and then move across over here away from the center of that star, notice that the crosshairs go to where the program thinks the center of the star is. So we'll move across. We'll do the last star. Okay, so we've measured those 6 stars. If we go up here and look at our summary table, we have 6 stars here which give us our separation in arc seconds, our position angle in degrees, and our delta magnitude. And there is other information present here as well. For example, Julian date. Now you can work out the mean standard deviation, the maximum and minimum values by going to results. Click on Summarise. Now, you want to save this file as a comma separated value file so you can open it in Excel. So let's call it Table 1 LDS64.CSV. We're going to save that. Actually, you can probably don't have to put .csv. If you go in results and then go to options, you can say file extension for tables is CSV and it should save it like that already. So click on OK. All right, let's close this. Let's close AstroImageJ. Let's go now to our table. Which should be on our screen. It's just over here. I'll bring it there. Let's double click that. And here we have our table of measurements. So I find that we don't really need the maximum and minimum, so I delete that. I would just tidy it up a bit. I insert a line here. Just spaces out things evenly. And then I would just move around the data a little bit so it's easier to read. But it's a personal preference and you can do what you like. So we're going to cut that and we're going to paste that. We're going to delete that. And here we have the measurements for LDS 64 for the position angle in degrees to 68.66, the arc length in arc seconds of 25.140, and then we've got the standard deviation. And here you can put in the standard error of the mean. I have a formula that I have in Speckle Toolbox, which is a little double star toolbox, which allows me to do some of these calculations. So here we've got the standard error of the mean. Copy. Close that. We're just going to insert that here. So it's actually C2 to C7, so we change that to C7. Press enter. And that should give us the standard error of the mean. If we drag that across there. It should give us the standard error of the mean for separation and delta magnitude. And then I would file and save that file. So there you have it. How to measure a set of images in AstroImageJ to give you position angle, separation and delta magnitude for further analysis.